Now, 2.8 takes 7. All right, so here we are. We're going to work on section 2.8, which is graphing or sketching inequalities. First thing we're going to start off with is linear inequalities, which we did before, but I will go through a review of that. And then we'll work with absolute value inequalities, which is kind of tie into what we did the last couple of days. So, first thing we're going to talk about is the review of different forms of equations of a line. So the first one that we see is y equals mx plus b, slope-intercept form. That's the way that we see most often. It is a form that's in your graphic calculator. M is going to be the slope. B is going to be your y-intercept, which is 0, comma b. You use this all the time. Remember, you want to plot the point first and then use the slope to come up with other points to be able to draw the graph. The next equation of a line, form of a line, is y minus y1 is equal to m parentheses x minus x1. This is called point slope form. M is the slope, and the point is x1, comma y1. I like to use this one a lot because honestly, it seems as if most of the problems that we're given, they give us a point and a slope, and then we have to go from there. So I think that this makes sense to use this form. Also, what I notice is if I solve this for y, so if I add this to the other side, I end up down here. Now look, there's my vertical stretch. There's my vertical movement. Here's my horizontal movement. So it's very much the same as what we just got done doing. The last form of line is standard form. Now, standard form, it would make sense that standard form is used the most, but honestly, you're really not. Standard form is used in a lot of word problems, which may result in not using it very much. So what it does do is it's really easy to graph using standard form because you can find the two intercepts really, really fast. You can put a 0 in for the y. That makes this b go away. So then you have ax is equal to c. Divide by a, you figure out what c is. So the intercept, the x-intercept is a comma 0. The y-intercept, same thing. Put a 0 in for the x, that goes away. Divide by b, you get 0 comma b. And that is the y-intercept. Plot those 2 points, connect the dots. It's used a lot. We use this form a lot, and especially in word problems. And we're going to do a few of those. So, when we talk about the boundary line, it's solid if it has part of an equal sign. So if it's less than or equal to or greater than or equal to, it's going to be a solid line. It's dashed if it's less than or greater than. And then we're going to worry about a test point. And I'll show you how to do this when we graph this here in this example. So the example that I had is going to look like this particular one. And I'm going to try to find my eraser. There it is. And let's go with the big one, and let's just get rid of all this stuff. So, for this particular problem, I'll just get rid of this too. We'll just start all over. For this particular problem, we're going to start off with an equation like y is less than, let's go 1/2 x minus 3. Okay, now this is in slope-intercept form. Your y-intercept is -3, so I plot that first. I go down 3, put it out. My slope is 1/2, so I go up 1 over 2. Up 1 over 2, up 1 over 2. I like to put a lot of these. The biggest reason I like to do that, a lot of them, is so that I can make it easier for me to graph this. Okay, now this is less than, so that means my line is going to be dashed. Okay, so now that I have this, now I'm going to choose my test point. Every time that I can, I'm going to choose a test point of 0, 0. If this line doesn't go through that point, use that point. It's just the easiest point that you can. So there's my test point. Now, once I decide that this is my yes side, whatever side in relationship to this line and 0, 0, that becomes my yes side. This is my no. Your yes side will always have your test point. So now I try it. I put the 0 in for the y, and I put the 0 in for the x, and I do the math. So 0 less than -3. No, it's not. So I shade the no side. There we go. Let's look at another one. Let's say I have an equation of 2x minus 3y is greater than or equal to 12. Now this is in standard form. You could convert it, okay? I could subtract the 2x from both sides and then divide everything by -3. Remember to change the sign. So this is 2/3 x minus 4 and graph that. I don't know if I want to do that. So what I would really prefer to do is I'd really prefer to find the intercepts. So 2x is greater than or equal to 6, x is greater than or equal to 3. Okay, so that means this intercept is at 3, 0. Now to figure out the y-intercept, I'm going to put a 0 in for the x. And it doesn't matter what this symbol is. I always treat it as an equal sign. This goes away, so -3y is greater than or equal to 12. Y is less than or equal to -4. I would treat it as an equal sign. So I'm going to go down here to -4, put it down. All I'm looking for is that point because this is 0, -4. Now, this particular problem, the original sign was greater than or equal to. That's a solid line. So I'm going to just try to connect these two dots. So I would go up 3, 1, over 3, and up 4. So 1, 2, 3, 4, 1, 2, 3. There's that other point just for me to graph. This is a solid line. Okay. 0, 0. Yes side, no side. So I'm going to put a 0 in for x and a 0 in for y. Is 0 greater than or equal to 12? Well, once again, it's no. Shade the no side. And one last one for us to do here. Let's say that I have y is greater than or equal to 3x. Okay, this is in slope-intercept form. My slope is 3 over 1, and my point is 0, 0. So I'll put a dot at 0, 0. Go up 3, 1, 2, 3 over 1. 1, 2, 3. 1, 2, 3 over 1. 1, 2, 3 over 1. Greater than or equal to, solid line. Okay, now here's my problem. It goes through 0, 0. So I got to choose one that's not that way. And it really doesn't make any difference. Honestly, I don't make my x 0. So that means I'm looking for a number up here. So let's choose this one. It makes this my yes side, this my no side. So this point that I just chose was 0, 5. So I put the 5 in for y, and 3 times 0, so it's 5 greater than or equal to 0. And that's yes, 5 is greater than or equal to that, so I'm going to shade towards the yes side. Okay. Now the things I always do, always double check to make sure my line is correct. It's got to be solid. My shading makes sense. I'm good from there. So graphing inequalities is a little different. It's the same as I do before. So if I have this format, the thing I look for is what's the vertex. The vertex is going to be h comma k. And a tells me the stretch. Remember, normal goes 1, 1, 2, 2, -1, 1, -2, 2. So I'm going to apply that to these. Now again, borderline, part of an equal sign, it's solid, dashed if it's not. Test point and solution, same type of way. Starting off with this one, okay? I know I'm going to go, this tells me right 2, up 3. So there's my vertex, right 2, up 3. Put my dot. It's not being stretched, so it's over 1, up 1. Over 1, up 1, over 1, up 1. Same thing on the other side. This is less than, so I'm going to put that dash line in here. Now again, same thing. There's my 0, 0. That's my practice sign. This is the yes side. This is the no side. So 0 greater than 0. The absolute value is 0 minus 2 plus 3 is 0 greater than or less than 2 plus 3 is 0 less than 5. The answer is yes. JDS side. Everything but that V and inside of that. Trying another one. Okay, this vertex, -1, -2, axis of symmetry is x equals -1. -1, -2. It is reflected, but not stretched. So over 1, down 1. Then you check to see, okay, solid lines because it's got part and equal sign. Okay, there's my test point. Makes this a yes, that makes this a no. So is 0 greater than or equal to the opposite of 0 plus 1 minus 2. The absolute value is 0 plus 1 minus 2. So 0 bigger than the, that's -1 minus 2. Is 0 greater than or equal to -3? That seems to be yes to me. JDS side. Oh, what about this? I don't like this 2 on this side, so let's add that 2 to both sides. Okay, I can do this. Vertex is at 2, 3. 2, 3. Okay, axis symmetry is right through here. It's reflected but not stretched. It's a less than, so I'm going to put a dash line in here. Here's my test point. That makes this the yes side and this the no side. So I don't kind of look at this one. It doesn't make any difference. 0 minus 2 is greater than -0 minus 2, the absolute of that, plus 1. -2 is greater than the absolute value of -2 plus 1. So the opposite of the absolute value. So this is -2 greater than 2 plus 1. It is -2 greater than 3. That's a no. Shade the no side. Now, writing the rule from this is an interesting problem. It's kind of hard. So I'm going to start off with this. I know it's going to be like this. How do I know that? We got a dash line and it's a V. That V is centered at over 1 to the right, so it's -1. But I don't go up any, so I'm going to leave that alone. It's not stretched because over 1 up 1 gets to it. It's not reflected, so over 1 up 1, so everything's good. Now I have to decide, is it a greater than or a less than? I know it's either greater than or less than because it's a dash line. So I'm put my 0, 0, making this the yes side, this is the no side. Now what I'm thinking is I want to come up with something that 0, 0 is not the answer. So 0, 0 minus 1, absolute value. 0, 1. I want this to be no, this not to be true. So if I put is 0 greater than 1, is that not true? It is not true. 0 is not greater than 1. That's my sign. Okay, this one. Alright, so y absolute value x minus 2 doesn't go up any. 1, 1, no stretch. Gotta decide about the sign. It's dash, it's gotta be either greater than or less than. Okay, test point 0, 0. Making this yes side, this is no. I gotta make it not right. So 0 and 0 minus 2. 0, absolute value negative 2 is 2. I want this to be false. So that means it's got to be greater than. There we go. This is a harder problem. Let's try this one. So 0, y, absolute value, on the right 1, minus 1, and down 2. Saw a line, less than or equal to, greater than or equal to. Oh, it goes through my test point. So let's try a new one. Let's put 2, 0. I want this to be true. So my test point is 0, 2, sorry. So let's put a 2 in for y, and a 0 in for x. Now this is the absolute value of negative 1 minus 2. 2, and the absolute value of negative 1 is 1. So this is 1 minus 2, negative 1. I want this to be true, so greater than or equal to. There's that one. Try this one. Okay, again, y. The order pair is over 1 to the right and down 2. Okay, now if I pick this particular point right here, making this the yes side and this the no side. So I want this to be false. So let's put this point in there. 2 goes in for the y, and 0 goes in for the x. This is 1. And I want this to be false. So I'm going to say it's less than or equal to. That way we shade towards the no side. Okay, you don't have to complete this because we never assigned this, but your assignment today is to work on this. Sorry about it being so late, but I just hasn't worked too much today. All right, you have a good night, and we'll see you hopefully tomorrow. Okay, bye-bye.